You've been there, right? You ask an AI a question, and it gives you an answer that sounds super confident, but is just completely wrong. We call that hallucination, and honestly, it's one of the biggest headaches in AI right now. So what if we could fix that? What if we could just give the AI an open book during its test? Well, that's pretty much exactly what Retrieval-Augmented Generation, or RAG as we'll be calling it, is designed to do. Okay, so here's the game plan for this explainer. First, we're going to talk about why AIs even need this kind of help. Then, we'll actually build a basic RAG system from the ground up. From there, we'll level up to smarter architectures, figure out how to take a system from just good to great, and wrap up with a look at the challenges and what's next on the horizon.
All right, first things first. To really get why RAG is such a massive deal, we have to understand the core problem with most AI models. And it all boils down to this idea of a closed book test.
So yeah, the big question is, why do AIs hallucinate? I mean, why do these super powerful models sometimes just make stuff up? It really all comes down to one thing: how they get their information. Okay, think about it like this. A standard large language model, or LLM, is basically like a student who studied like crazy for a test, but now has to take it with a completely closed book. All its knowledge is just what it can remember from its training data, which is totally static and can be months or even years old. It can't check its facts. But a RAG-powered LLM, that's the student who gets to bring the entire library to the exam. It's an open book test. It can access a huge live library of information before it even tries to give you an answer.
And this whole open book idea has some seriously huge benefits. For starters, it slashes those pesky hallucinations because the AI's answers are now grounded in actual verifiable data. Second, it can access up-to-the-minute information, not old training data. You can also specialize it for super specific fields, like medicine or finance, by just giving it the right books to read. And maybe the best part? It's way more cost-effective than trying to retrain a massive model from scratch every time you want to update its knowledge.
Okay, so that all sounds great, right? But how do we actually build one of these things? How do you give an AI its own personal library? Well, it breaks down into a really elegant three-step process.
This is the basic assembly line for any RAG system. First, you take all your documents, your entire knowledge base, and you chop them up into smaller, digestible pieces. We call those chunks. Next, and this is the really clever part, you convert those chunks of text into numerical representations, or vectors. This process is called embedding, and it basically captures the meaning of the text in a way a computer can understand. And finally, when you ask a question, the system searches through all those vectors to find the chunks that are most relevant to your query. It's like finding the exact right paragraphs across 1,000 different books.
Now that first step, chunking, is absolutely crucial. It's a bit of a Goldilocks problem. If your chunks are too big, the AI might miss the specific detail it needs. But if they're too small, it loses the surrounding context. So the best practice is usually to aim for somewhere between 500 and 1,000 tokens. And you can think of a token as roughly a word or part of a word. You also want a little bit of overlap between the chunks, say 10 to 20%, just to make sure you don't accidentally slice a key idea right in half.
So you've got all these embedded chunks of information. Where do you put them? Well, they live in a special kind of library built just for this purpose, called a vector database. Think of it this way. A normal database is great for keyword searches, like finding the word apple. But a vector database is designed to search by meaning, so it can find documents about fruit or tech companies, even if the word apple isn't there. It's incredibly powerful and super fast.
Okay, so we've got the fundamentals down. That's our basic RAG system. But now, it's time to level up. Because while that simple setup is good, the real magic happens when we start looking at more advanced and flexible architectures.
You can really think about RAG evolving in 3 distinct stages. What we just built is often called naive RAG. It's that simple, straight-line process. Then you have advanced RAG. This is where we add some extra smarts, like pre-processing the user's question to make it clearer, or post-processing the search results to re-rank them for relevance. And finally, you get to modular RAG, which is like a Lego set. It's a super flexible system where you can swap out different pieces, different search methods, different models, to build the perfect RAG for your specific job.
So, one of the coolest advanced techniques is something called hybrid search. It's exactly what it sounds like. It combines the best of old school and new school search. You get the precision of keyword search, which is perfect for finding specific names, product codes, or acronyms, and you blend it with the power of modern semantic search, which understands the actual meaning and intent of your question. Put them together, and you get a massive boost in finding the right information.
But wait, it gets even smarter than that. We're now seeing architectures like corrective RAG, or CRAG, that basically add a layer of self-correction. The system doesn't just blindly trust what it finds. It actually evaluates the retrieved information. It asks itself, is this relevant? Is this high quality? And if the answer is no, it has options. It can fall back on its own built-in knowledge, or it can decide to try searching again with a totally different approach. It's like it's learning to be a better researcher in real time.
So, you've put all this work into building a smart RAG system. That's awesome, but how do you actually know it's any good? How do you measure its performance and make it even better? Well, that's where evaluation comes in.
When we evaluate a RAG system, we're really looking at two separate things. First, there's the retrieval part. The basic question is, did it find the right information? We use metrics like precision and recall to figure out how accurate and thorough that search was. But then there's the second part, generation. And the question here is, did the AI actually use that information correctly and faithfully in its answer? We measure that with things like faithfulness, to make sure it's not making stuff up, and relevance, to make sure the answer actually makes sense.
Now, as you can imagine, trying to check all of this by hand would be an absolute nightmare, especially for a big system. And that's exactly why developers use frameworks like RAGAs. It gives them a standard toolkit to automatically test and score their entire RAG pipeline from start to finish. This makes it so much easier to track improvements and compare different versions.
And of course, for any of this to be useful in the real world, it has to be fast and efficient. So engineers have a whole toolbox of tricks to optimize performance. Things like automatically rewriting a user's messy query to be more precise, or compressing the context it finds so it can feed more useful info to the AI. These are the kinds of optimizations that take a RAG system from a cool experiment to a rock-solid, production-ready tool.
Look, RAG is an incredibly powerful tool, for sure. But let's be real, it's not a silver bullet. It doesn't solve every problem, and there are still some pretty big challenges to tackle as we move forward.
Yeah, even with all the advanced bells and whistles, things can still go sideways. Your chunking strategy might slice a critical idea in two. The search might just flat out miss the one perfect document it needed. There's even this weird issue where AIs sometimes ignore information if it's buried in the middle of a big block of text. And on top of all that, you have the constant, never-ending job of making sure your knowledge library isn't getting stale.
So what's the next big thing? Where does this all go from here? Well, the future looks to be something called agentic RAG. This is a huge leap. Instead of just doing a one-shot search, the AI starts to act like a true research assistant. It can look at your complex question, reason about it, and break it down into a multi-step plan. It might perform several different searches, and it can even come back and ask you clarifying questions to make sure it's on the right track.
And that really leaves us with a pretty mind-bending thought to wrap up on. RAG started as a way to help an AI find better answers, but agentic RAG is all about teaching it how to ask better questions. So what happens then? What new worlds open up when our AI tools stop being just encyclopedias and start becoming our active partners in the search for knowledge?